Já. Og eru þeim? Hvað gerist? Ekki nógu. Það er rakkur að mögu til okkur, sko. Ég býð ykkur hjartanlega velkomna á þennan fund hjá okkur sem heitir, við kallum á íslensku Öryggi í netheimum, Cyber Security, og með okkur í dag er Steffensen, specialist on this topic from Öryggi. En eins og við þekkjum og fyrir mér hérna, þetta er mjög lifandi mál sem að verða stærra og stærra eftir því sem að þessi tölvuveröld okkar þróast og þið þekkið allir þetta dæmi árásir inn í tölvur fyrirtækja og getur sagt orkufyrirtæki þetta hluti sem þeir eru mjög hræddir við að einhverjir sem eiga ekki að komast inn geta farið að fikta og djöflast og skemmta sig við það að slá einhver út og svo framvegis og skemma. Þannig að þetta er high topic hjá orkufyrirtækjum í dag og eins og mörgum sviðum þá er mikil þróun í þessu og þá hvaða leiðir og lausnir eru til og hvaða leiðir og lausnir þá fyrirtæki sem bjóða þessa þjónustu eru að bjóða. Það er kannski ekki að tala hugbúnaðarfyrirtækin heldur þá þeir sem framleiðendur og eru að selja búnað eins og ABB, hvaða lausnir þeir bjóða viðskiptavinum sínum til þess að tengja og vera með örugg netkerfi tengda inn á þeirra búnað eins og stjórnkerfi og fleira. Þannig að það er svona megin atriði sem förum gegnum þetta. Like I said, Per will lead this presentation and so you just take over.
Thank you.
Thank you.
Thank you very much. And thank you for coming. Using a little time to go into this very hot topic, you could say. I will try to look at it from a, you could say, professional point of view. I'm not talking so much about iPhone devices and things like that, how you can be hacked at home. So I would like to look at it from a company-wise and professional point of view. This is a very hot topic and very serious matter, actually. It's so that I know that both intelligence services around Europe and the world and authorities are considering cybersecurity as being or cyber attacks to be the largest threat to our infrastructure in modern society today. That's why also, for instance, in Denmark, the largest single area in the budget for the intelligence service is cybersecurity at the moment. Giving a signal that this is important and the threat will be increasing as we have been seeing in the last couple of years. Before going further, I would like just to give a few words about me. This presentation is not about me, but then you know my background. I'm an electrical engineer, been working with automation, IT systems and process control for more than 30 years. I've also been working with 20 projects out of Denmark to China and Mongolia. For instance, in the district heating business, supplying a total district heating system, including pipes and everything. Nowadays, I'm working in our automation business in Denmark. I'm taking care of power and utility customers in half of Denmark and then in Oslo. So I'll also just have very few slides about ABB. This is about ABB in Denmark. A little less than 500 persons, 2.5 billion Danish kroner, that's 350 million euro in revenue per year. Focus areas, safety. When we say safety here, it's not about process safety, it's about human safety, working conditions, We have very high focus on that, and we have actually, through dedicated efforts and improvements, reduced the accidents and incidents with almost 80%. So we're down to 20% of what we had only a couple of years ago. ABB globally, this is how we see the world. We sell products, we sell systems, and we sell service and software. Products is more than half. If we go to the business areas, we have the utilities, the industry, and then the fast-growing transport and infrastructure area. And globally, we are more or less even divided into the three segments, as you could say, the New World, the Americas, and Europe, which is, to us, a very strong point, because we are then very good foundation in all kinds of businesses and in all kinds of the world, all parts of the world. Gives us a more stable business. And 132,000 is not really correct. We are almost 140,000 today, because we this year have acquired an automation company called B&R Automation, producing PLCs and controllers for machine control. And these are the areas we are covering. High growth in building, intelligent building automation. Infrastructure is about charging electrical vehicles in all aspects, also ferry boats. Earlier this year we commissioned our electrical powered ferries from Helsingør in Denmark to Helsingborg in Sweden. So these big ferries are now operated by electrical power or driven by electrical power, and they are charged in the harbors using robot charging. Interesting. Of course, the industry, as you can see, a big part of our business, all kinds of electrical products and automation. The multi-utility, multi-energy sector, both production, transmission and distribution. No more words about ABB. We go to cybersecurity, and attacks happen. You know, most people know about that. The Stuxnet in Iran some years ago, the German steelworks, and also a yearly tradition in Ukraine that someone is attacking the electrical distribution every year at Christmas time. It happens 2 years, so we'll see what happened in 2017. This is the threat we are facing, or part of it, and you probably know about this. It can affect a lot of things. If we look at one of the largest players in the world on shipping, the Maersk company was struck by an attack here in June, which were laying down their business, their IT systems, for 1 or 2 weeks. So they had a direct loss of about $300 million US, is what they say themselves. But apart from that, they have an image loss, because Maersk is known for supplying the goods, the containers, in time. Now they didn't even know where the containers were. So containers with food supply had to be found and driven by trucks around Europe. So that is what can happen, even if Maersk believe they have a perfect cybersecurity protection. So we all know about this. What about you? Have you any experience with cyber attacks or things laying down your system or just disturbing you? Yeah. That's becoming more and more common, that we talk about it, that we tell about it, and we communicate about it. Only a few years ago, it was maybe the attitude to just keep it out of discussion, because nobody wanted to tell them they have been attacked. Now it's so common that I don't know how it is in Iceland, but in Denmark, if we are now, every company have to report it to the police, to the intelligence service when they're attacked. That's simply a part of the regulations in this area. So, then don't do like this. There's a French TV channel, as you can see up here in the middle of the arrow, they have their password to their YouTube account on a poster, and later that evening that channel was closed and their website was hacked. So that's not the way to do it. Going into more detail, going into the agenda, as I said before, I'm not going to talk about how someone can hack your home network or your scary things about what can happen if someone takes control of your smartphone or whatever. I'm going to look at it from a product and system-wise perspective. We've already looked into the cybersecurity challenge. So the basic about cybersecurity is to prevent this situation where system failure is happening. And targeted attacks, you all know about that. Hackers, people trying to enforce their way into your IT infrastructure. The other way is malicious software. This is maybe not attacks, it can be, as shown here on the slide, some antivirus, some virus, some worms, some ransomware entering by USB stick or whatever other equipment. The most common is maybe emails where you get people to click on some link and then the problem is ongoing. But what is often maybe not so much focused on is people inside the organization to make some faults, maybe not intended, to maybe download some interesting software, maybe taking a USB stick from home, maybe connect some unauthorized computer. That is also very important, and we will return to that later on. But don't consider this as just a threat from outside. Mistakes inside can also have serious effects. And then a very important issue about cybersecurity and best practice is that this is not just about operation or technology. It's also about people and about operation and organization. Looking here to the right, you can see this is a lot of layers to establish around your products or your installation to protect against cyber attacks. And we often maybe have had the attitude that, okay, I need some antivirus software and I need a firewall, and then everything's fine. But there's a lot of other issues related to cybersecurity. Take the outer layer in this shell here. This is physical security. How easy is it to go into your office or your installation, open the door and find the switch and plug in a cable? How easy is it physically to go into your installations? Do you have procedures in place? Do you have management support to these measures that is necessary? And then, of course, the firewall, the system architecture, the way you build it up, divide it into segments and so on. Account management, taking care of your login accounts, make sure that it's not some old configuration from 5 years ago that is still active and people are still registered as users even though they're not employed anymore, or things like that. And of course, antivirus and security updates of the software. That is well known by most and practiced many places. But all the other aspects are just as important. So, it's also, I think it's also recognized by many working with this at the moment that there's no 100% security. And it's not, cybersecurity is not a product, it's not something you can buy, it's not something you can say, I set up a firewall and I'm secure. It's a moving target all the time. The first slide I showed you with the cyber attack in the uranium plant was actually done without, they didn't have any internet connections at all. So the attack was established by someone probably using other ways in. So it's also, as stated here in the last sentence, it's also about using your money and your efforts on the right thing. It's finding a balance between cost and safety. Because as we can, no, that's the next one. Sorry, it's also about, it's a risk management. It's evaluate what is the highest risks here, and that we will attend first. And then I would like to discuss the current risk approach from a number of companies I've been working with for a number of years. That is the Dong Energy in Denmark, the power plant company, among other things. They say, okay, of course it's still important to prevent cyber attacks in the traditional way. But that's not enough anymore, because in the future it's only a matter of time before they will be attacked and it will succeed. They can't simply make a strategy to say we will just prevent attacks. Sometimes it will happen, and therefore a disaster recovery plan must be in place. Everybody must know what to do if they are attacked. And it's a quite complicated issue actually. Looking into a company like that with distributed power production, power plants in the same intranet structure. They have production planning, collecting data from all the sites, deciding which plants will run. So everything is interconnected. So in a case of attack, what is the right thing to do? Is it to cut everything off? Is it to close down the plant with the attack? How do we protect the rest of the plants? Because they need to keep some of them running to keep up the electrical supply in a country. So it's quite complicated because there are different strategies depending on what is going on. So that's what we're working with them. Simply make sure that there's offline backups. Because what we see is that companies being attacked, they have a backup device, a NAS device connected to the network, and this device is also influenced by the attack. So you have to make sure that there's a backup of the software and the products software somewhere that is not possible to attack from cybersecurity attacks on the network. Emergency plans, as I mentioned, people must know what to do, which plug to take out, what parts to isolate, network isolation, and have a recovery plan that is tested and rehearsed so everybody knows what to do, because time is critical in that situation. Even discussing with them about their systems, that there might be a need, it's not decided yet, to have a shadow system running, a full system of running, maybe in an ABB location without connection to the outside in the basement, and in case of an attack and everything is out of operation in a plant, you can simply take the server system on your shoulder and go to the plant and plug it in, make sure you are isolated, and then get up running again. That's quite drastic, because of course there's some cost about having a system running in parallel and keep that updated in a cybersecurity way. So this is what being on the desk at the moment for future prevention of cyber attacks. And from a total perspective, it's of course the cybersecurity approach is of course to take it into account already in the product design and product manufacturing and software development, to be sure that all these measures are a part of a project when you're building or extending a system, so that you don't drag some cyber software or some malicious software in during the process of a project or implementing the system. And then of course in the operation phase, the maintenance phase, always to keep track of updating what is necessary. Things that we also require from our suppliers, and things that you can require from us as a supplier, or should require from us as a supplier. And then for me, it's a very important issue here. Looking into cybersecurity, it has often been considered as something for systems, something for a network, something for a control system or SCADA system, or whatever. But it is also very important to look at products, to keep track or make sure that products are also protected. Because if we're talking, you saw someone maybe earlier today saw something about our new robots. It could be a network switch, it can be protective equipment, relay protection, RTUs, frequency converter drives, PLCs and controllers. All of these equipment are often, or almost all of them in these new plants are connected to some network. This means that the traditional approach is not valid anymore. Often what I call the machine mindset. I buy this equipment, consider it as a mechanical machine, I put it in here and it should operate for 10 years, I don't do anything about it. It doesn't go anymore. Hackers, malicious software is working with trying to learn about these kind of equipment because they might be interesting if they're related to electrical supply, for instance. So the software will have to be updated. And therefore ongoing software update of these products will have to be considered as part of the cybersecurity plan. Because there might be holes in the old software that was designed maybe some years ago. There might be finding some way to attack these equipment and get that way into the network maybe. So firmware in these components will have the basic software, IP connected software, whatever, will have to be updated at a reasonable frequency. And also configurations tools are often forgotten. If you have relays, you have PLCs, there's often some kind of configuration tool, programming tool running on a laptop you have maybe left on the network or whatever. These things will also have to be considered and be a part of your software update in your plant or in your company. So that is our recommendation, to take these product updates into an updating plan, as you often do with, for instance, control systems. Yeah, then we talked a little bit in the beginning about risk assessment. And maybe just now we're talking about, products here. Some of you saw this computer earlier today. It's a full-size computer, same power as much say a PC from a couple of years ago. You can buy it for, what was it, $10 US or something like that. You can put it on, you can turn it on and connect it to the internet. It can be an access point on the internet. And IT cybersecurity experts are testing if we put up equipment like that on the open internet. How long time do we have before someone tries to get in? What do you think, if you put this on the net, how long time in average will it take before you have the first attempt to attack equipment like that? You have a guess? 3 to 4 minutes. I didn't really believe it, but it seems to be correct that these scanning software you can buy on the dark internet. A lot of them is running on the net, trying to find out is there an open way in somewhere, and somebody finds this IP address within 5 minutes. So if you take a new equipment, put on the net, you have 5 minutes to protect it, if you haven't considered it before. That's harsh conditions to work with. I don't say it will be evil attack in 5 minutes, but it could be. So risk assessment, looking into the risks of this. We tend to work from these guidelines. There are a lot of standard guidelines, we return to that. Make a risk assessment, evaluate how is the situation in your plant, get somebody from outside to go to your company or to go to your installation and make an assessment to have a full picture of what is the situation, what is the risks. Management buy-in, meaning, which is a difficult part often, because management often do not understand this problem to the depth. But it's very important to have these measures in place and get a good procedure about cybersecurity that management is actually backing up and supporting this. Make a security policy, and then, again, as we have discussed before, balance the value against the effect. Where is it to use most resources in the beginning, and how shall we prioritize our resources? We can't do anything, we can't get 100% safety, so how to address this? And work with your suppliers and require that your suppliers can support you and document what they have in this aspect of cybersecurity. Be aware of to register your incidents. Report them internally and externally. And especially train your staff, as I said before. Okay, we have an attack, someone have found out that something is going on, what to do, who should do what. Very important. And then evaluate your policy, and then have this evaluated. As any other quality assurance system or safety working conditions systems where you have a process running over the years to follow up and see if what you have done is actually working. And this year, as I have said before, if you have all the money in the world, you can get a very high level. So it's a matter of finding a point where you believe that your investment, your current use of money for this is giving good value. A hard decision, of course, but it's also important to tell your management that you can't have the highest level without all the money in the world. It's a decision to make. About risk assessment, we have set up an ABB system where we can offer a fingerprint test, fingerprint evaluation as a start of cybersecurity measures, where we can go to your company, go to your plant, and we can not only look at the technical issues, maybe test your system, but we can also ask about how are you acting? What about your physical security? Do you use passwords? Do you have individual passwords? Are they maintained and changed frequently? And all these things that are not how you act, how you operate. And then we can fill all these data into a report and come up with a spider diagram like this. And these two issues here, and this one is critical. Here it's low risk. So you can get a picture like that saying, where is it that we have the highest risk? Where should we start to do an effort? So this is also a very good documentation for your own use, for your management use, and for also in the future authorities coming to check you. And we often talk about implementing cyber defense. We'll deep in the depth. And as I said, there's a lot of standards applying in different areas. Often this IC standard is referred to as a good starting point. It is, of course, maybe a harsh thing to start with, many pages, but anyway, there are some guidelines giving you a good idea of what to do building up a cybersecurity defense. And I can say that, I don't know, do you have any new regulation law or regulations in Iceland on this area? We have just had in Denmark a new regulation related to power producers and power transmission and distribution. So there's new strict rules on how to act and how to document that. And I'm sure there will come a lot of that, probably also to you, because it is so important issue in many countries, in many areas. This standard gives you best practice, so maybe that's good advice to find here, both around integrators like us and operators, and about system producers, how to act. These are guidelines, but it's a good way to start. And then we often work with cybersecurity in the whole product lifecycle, according to what is some smart guy have found out is SD, the third, and C for communication. So that is security by design. This is our task. That we put in the design requirements when we make changes, when we make new products, when we make new software, to consider cybersecurity from the beginning. And this is why many of the updates on firmware for components on controllers and many updates on control systems these days are actually related to cybersecurity. Security by default, that is using good practice on how to configure your component or your product to build in defense and set up the right parameters, maybe to make sure that if you have some network connections that only the ports used are open, for instance, maybe to make sure that you set up the right software setup for users, and make sure that you do what is protecting your installation in the best way, and not just leave every door open. And then again, I have said before, in the deployment, both in product phase and in operation and maintenance phase. And then again, communication, we return to that. According to this IC standard, there are some areas here where you can get some help on how to authentication control, users, access rights, only give access to the person who need to have access to different parts. I know that for some systems, operating systems or control systems, SCADA, it's often easy that the system is always logged on and everybody can go in and out and use it. That's not so good anymore. You need to have your own password, you log out, log in and log over between users. Just as one example. I do not intend to go through all of this in detail, but there's a lot of consideration about confidentiality. Make sure that the information, the data is not giving access to this information for persons who do not need it or are not allowed to get it. It should not be possible just to go into your system and dig into your database and extract whatever data you want. This is the reason why the new data collection systems we are looking into in our new ability platform is also working with a principle that the critical system is pushing data outside the critical part of the network to an external database. So people using data from your operation do not have to get access into the whole part of the network, the kernel of your system. Just an example. Taking a few examples of this, the user access, passwords, logins, individual passwords, that someone is maintaining that database of users. Make sure that Peter or Sigurd or whoever is not employed anymore do not have a login. Make sure that you do not give external people access unless you're totally sure that it's the authorized way to do. Remote access, we return to that. To harden that, to make it more difficult to attack these remote logins. Remote access to your installation is often one of the highest risks. And who should do what and where are they allowed to do it. Thus, to use user control is important. Data confidentiality. Make sure that you don't just take things out on a USB stick, bring it somewhere else, unless it's encrypted. Or maybe never do it, if it's not necessary. The remote connection. Make sure that this is not just you just don't share your screens with someone external without any security measures. And of course, if you take something out of operation, make sure you clean it for data. Just example of the measures you have to consider in your cybersecurity activities. To be able to know what is going on, to be able to learn and to act on this, it's also important to collect data in the system about what is actually going on, to log, have a log, an event log, what is going on, to register your data so that you're able to analyze if there are any threats. It could be inside the company, it could be a service provider like ABB. This is more or less the same again as I showed before, that we are in ABB, we are more or less involved in the whole life cycle phase here, from the design and produce a product or some software, through our project execution. It might be ABB executing a project, it might be you, it might be someone else, but even it's still important to have these cybersecurity considerations as a part of your project setup and your product and quality management. And of course in the maintenance phase for updating and concurrent checking of security. And therefore we operate with robustness testing of our products and our software, also from independent test centers, device security access center, assurance center, and this is just to scan the product for vulnerabilities and to let network plotting on the system to see how it acts if you're just shooting at the system from the network, checking for unknown faults or vulnerabilities. This is the testing that we are doing at our products. Now, I talked a lot about products, but also, of course, the system structure of your. This is a control system. Could be any. Of course, this is made from ABB drawing, but it could be any control system, SCADA system, other product system. So we recommend very much to consider how to design the network, divide it up into zones, so we have separated the different parts of the system, and of course applying firewalls on these network segmentations. I know our engineering people and our customers say this is difficult. It was much easier before, where everything was simply open connected and we just had one firewall here to the outside world. But I'm afraid to say this is, from our point of view, not enough anymore. Because if someone intruder get into the system, it's also important that it's difficult to go down to the critical parts. This could be a turbine control in a power plant, so it should be very difficult to go there as a network hacker. Secure communication protocols, that the equipment is, switches is protected for these storms from, sometimes you buy these, you can buy for maybe $50 US, you can buy some software on the internet which is just bombarding your network with attacks or tries to get in. So it's also important your network equipment is protected and can live with these attacks. Of course, all the other issues, antivirus, malware protection, even maybe whitelisting, which is a way of telling that only these applications are allowed to run on this computer. A more safe way of handling than just antivirus software. Access control, we talked about that. Windows user authentication usernames and so on, according to Windows setup. And the remote access is very important also to have this separated. So all these measures is important in design, and it's very difficult to do in existing systems. But anyway, still important. Firewall management, make sure that your firewalls are updated. Make sure that your settings of these components are backed up in a safe way. The same actually with, for instance, configuration of protection relay. It could be a program in a controller. Make sure that these software are safely backed up, because if something happens, you should be able to restore again and get on the feet and operate as soon as possible. Firewall settings are often quite complicated today, and it's often forgotten to take a backup of the settings. Make sure to use newest platforms of basic software like Windows Server and Windows 10, for instance, Windows 8, which can be updated, which are supported from Microsoft. And they, of course, still support Windows 7, but it will end soon. And therefore, updating of systems so that they can run on these platforms will be an important issue. We have made an agreement or cooperation with Microsoft to even extend the normal lifetime of these platforms, because what is often annoying our customers is that they have to update all the time with all new functions that is actually not needed in a system. So if we install a configuration like that today, we can actually, together with Microsoft, say this can live at least 8 years. You still have to have the security updates, of course, but you don't have to upgrade every now and then, because there's a cost related to that. So that's what we call extended or long-term service for these platforms. And then, of course, require of your supplier that they can document their compliance with cybersecurity requirements. Maintaining the system, the last part, and again, this good circle, you could say, maybe start with this fingerprint analysis I mentioned, where we get the status of your system and your setup with products. Cooperation between companies who operate the system and suppliers is very important. When you install new equipment, upgrade old equipment, make sure that the specialist you require to do that, whether it's your own or SABB or someone else, is also aware and full cybersecurity compliant. And then monitor your system. This is about same again. Make sure that your basic software is kept updated. Microsoft monthly, quarterly, we recommend to have a server called a Visu server, window update server, where the patches for Windows is, for our system, is tested by ABB. Don't just go and install a new patch without knowing that the system will keep on running. So we have a global test center for these patches. If you have a service software update agreement with us, we can distribute these updates to this Visu server, and then it will push it to the individual computers and servers in your system. It's a very effective way of doing it, instead of going manually to each computer and installing the new patches. The same with the antivirus, whether it's McAfee or Symantec. Also in McAfee we often use that, the ePro server, as the principle the same. You get the new updates into a dedicated server and push it to the individual machines. A good way of working. Additional efforts maybe compared to what we used to do, but it's highly recommended to do it. Some 1.5 years ago I had a discussion with a utility manager who were trying to see if the service agreement we had could be at a lower cost. And I said to him I would recommend it at a higher cost, not of course because I would like to sell him more, but because he didn't have these updates. But he wouldn't pay for that, so we agreed to leave the service agreement at that level. And then here this spring he had a ransomware attack. They didn't manage to pull down the whole control system, but it was a redundant system, so one part of it survived. But afterwards we were using more than 100 man hours, 120 man hours to restore and check and reinstall the system. He also had to use other consultants to assist, and to accountants who came in also on cybersecurity. So I would guess that his cost was quite high on this, maybe some 30,000 euro or 40,000 euro. But it's only one action. So now he have accepted to include that in the service group, because he could see that it was a fault, that he didn't have it before. So this is a must today. We can discuss the frequency. How often to do it? Should you do it daily, monthly with the virus? Should you do it monthly or quarterly with the patches from Microsoft? But you should do it. This is a system, actually, we approve these patches through the secure connection. We push it to this dedicated server for this purpose, and from here it's pushed to the individual computers. It can be done from remote, from our technicians, so you don't have to go to the plant, or you can do it yourself. So, we, as I have explained a lot of this, we will test these patches and publish them in a few days, and we will also publish the antivirus updates if you require that. And then we make sure that the system is still running. Can't have the challenge that if some patch comes up and you simply install it on your system, then some port is blocked, which is actually communicating to your controllers. That is not so good. So make sure that it's tested. Remote connection, as I said, a risk, high risk maybe. We have made a setup with a remote access platform. Not to go into details about this, but say that we have some central service or some service centers around the world where we can log in through our normal ABB network. Only the persons allowed to access a specific plant can log in. What is happening on the connection, we will register, we will have a log, we can document who have been connected. Then there's established a secured and encrypted line from our internal service center to a dedicated server here with which establishes and manages this connection. So what is the advantage here is that if an employee in ABB is not in ABB anymore, we will remove him. Here we do that all the time. Anyway, we've always done that. We'll remove him, his login will disappear, then he don't have access anymore. The customer here can decide who's allowed to access what. We can document who is authorized to connect and log in. And there's no other way you can go into your system than this one channel. The other way, of course, is what is quite common, to have some tokens, SMS passcode, where you log in, and then you get from your inside of your system via SMS, you get a code that you will have to enter as a double authentication. So you log in with a password, then you get an SMS code back, and then you have to fill that in to get access. That's also accepted many of our customers to be a safe way of having remote connections, because most companies, most plants would like to have the possibility of using external service engineers or a person that can have access, but do it in these safe ways. And we have also developed what we call a service port. Service port is our platform, server maybe, where we can run different software applications. And there's one application for cybersecurity, and there's a number of applications for different kind of systems that we have. The cybersecurity activity will simply scan your system, for instance, one time per day, in the night time, for instance, and it will register, are there any changes in port access on your network switches? Are there any new users? Are there new software that wasn't there yesterday? To register changes, because there's a lot of information in the software setup of a system and the computers connected, and it's very difficult for any person to overview everything. So this helps you with this kind of KPI overview, and you can say if this is a big bar here, then you can click on this and go down and see, okay, what server is it, and click on that server and say, okay, what is the problem? It's something software here that wasn't here yesterday. And then you can say, okay, the software is allowed to run here, and then this problem will not be registered anymore. So it gives you an overview, and this is running concurrently, maybe once a day. So this is a way of keeping track of what is happening in your system and giving you a report. And it can even be set up alarm limits. So it says that if any of these incidents here is higher than maybe 50% of what is expected from 1 to 100, then you get an alarm or an SMS. So you will get an alert. This is a software platform to keep track on cybersecurity in your system. This is not an immediate alert to you. I know that some of these power distribution and transmission companies are being monitored by also the intelligence service in Denmark, which are following the network very closely. So if you connect a computer, they will immediately get an alarm, say there's someone connected out on this plant that didn't used to be there. This is the next level. What we have here is a scan every day, so you can connect in between, but you will be registered that someone has done something. So that's a decision on what level do you need. It's very costly to have this online alert, because all details will have to be configured in that setup, in that test or monitoring software. So you have to be very precise in configuring it. This is high cost, so it's again the cost against the benefit. But this is a good compromise, and much better than just hoping that everything is fine. Then only a few slides left, and it's about communication, about reporting. There's There can be reporting from us if we find some vulnerability in our software. We have to be very careful about this announcements. Because if we find some fault, some open port that shouldn't be there, whatever, if we just put it on the internet, then you just help everybody who try to get in. So we would prefer only to give information to the customers that we know we have an agreement with to maintain the software that is real customers trust. So there's always a balance. But anyway, we have a website, we can come to that later, where you can see what is actually findings. We are also we are building up a service also to give you an announcement if something like these recent ransomware attacks have been in place, so you get an alert. Of course, you will also get it from other channels, but you can also get it from ABB. If you have some findings, it's of course also very important that you will report it to us. We are depending on what information we can get of any findings. So we are also through our website. You can give a report to us. I don't recommend you to put it on Facebook, but please tell us. And this is our website, abb.com/cybersecurity. You will find different areas, for instance, substation automation, process control, and so on. There's a specific information about different business areas. And as you can see here, you will also get information of, for instance, the NotPetya ransomware that was the latest major attack. We also have some information about that. You can always go in there, and if you are subscribing a software maintenance agreement with us, we're also having for some of the systems what we call a My Control System program, where you can get detailed information based on your software maintenance agreement and your login. So that's help to find here. Also, some of the issues I've been telling you today, you can also find that on our website. So, summary. It's a massive challenge. It's growing, and it will not disappear. And please remember that it's not just a matter of software, it's a matter of all these aspects I mentioned in the beginning. Keep your doors locked, make sure you use passwords and all these issues. And remember to also consider your components, your products that include software, not only your network or your system software. And find out what is your current status. Where are the holes in the wall in your system, in your company, and try to close the biggest holes first and get management involved. Keep them involved. That's the difficult part. And then use a structured approach to this. Take in eyes from the outside, not necessarily from ABB, but of course we'd like you to do so, but take in some eyes from outside that can give you very valuable input that you haven't considered yourself. So, to maintain the system, again, start with this maybe fingerprint assessment where you get a picture of what is the current status. Select products and systems where software can be maintained. Make sure that what you buy is something that can be updated. This morning there was a presentation about fast chargers for electrical cars, and as my colleague also explained, these fast chargers are often connected to the cloud, and by that way, from that channel we can also update, and we'll update the service as you do in your iPhone or in your electrical car. There's also software updates. This also goes for products here in our areas. Use individual login and passwords, not just the user code operator. use your individual with your name, with your own login. Consider very carefully how you build your systems and your network structure. Divide it into segments if possible. Make sure you have demilitarized zones and for the outside connections, double levels. Update your firewalls and your remote access points. It's one of the threats. And use a Windows platform where you can update your software frequently. Old Windows versions that are not possible to update is a no-go. And have ongoing services in place to have a procedure for updating your software. Make sure you do it, make sure we do it, or someone else do it. And the issue about the backups. I think we have also learned during the last year or two that a traditional backup servers and backup setup is not enough because they are also often online connected to the network. So make sure that both for all your product parameter setup and for your software that you have a backup that is safe. So you can recover again and get in operation as soon as possible after an attack. And then these communication I talked about, be aware about these alerts and communicate your own findings. Share your findings with the rest of the professional world. And use some software to monitor or if there are any alerts in your system. Not only antivirus check, but also if some software is installed during some commissioning and it hasn't been removed again or whatever. So, cybersecurity, it's not a one-time event, it's an ongoing process for probably the rest of our lifetime. And we are very happy to help you in that process. And I also think we're skilled to do so. That was about it. What do you think? Is it a big job or is it a piece of cake for you?
I think there are plenty of things to attend.
Yeah, there are many aspects.
Most of your service offerings are the monitoring solution. You're monitoring switches and floppy servers and workstations. How do you do that? Would you place your own server with your agents, somebody in a DMC?
Yes, we would establish a separate server or maybe a part of a virtual server system and run the software which then will check equipment and computers connected in the network structure you define as the target.
You will start by scanning the networks and establishing agents in a remote IO server.
No, we actually have this service platform installed on a server, and from there, preferably in your plant, and then this software will scan the rest of the computer in that network and give you a user interface with those findings and the KPIs.
Then you mentioned, so you will take a snapshot of the current status and monitor the changes.
Yeah, exactly.
And you talked about your own scanning, own security check. You have some kind of tool to do that.
Yeah.
Are you scanning only your own PLCs or equipment, or are you scanning any?
Combination actually. We are scanning also network equipment and to some extent external equipment. It depends. It is actually you could say, divided into two parts. The part that is related to the Windows setup, you can actually push that on any kind of system. But the parts related to ABB software, we can of course only supply the scanning framework for our own system setup. So different measures might be needed for other product vendors' systems. This was trying to give you an impression of the current status seen with our glasses at the moment, and of course also experience working with the power sector in Denmark, having these new requirements to live up to. You do not necessarily need to follow maybe the EU regulations, but they also on the way coming up with new requirements and standards for this. So I know often you follow EU regulations, so I guess you're looking forward to these requirements also. But please, more questions, we can take them outside. You're also very welcome to contact me in the future if you have more questions. Yeah.
Cybersecurity, say that it looks to me like you only have some kind of monitoring devices on server, monitoring your own equipment, taking status of that. Is that the only thing? It's hardly cybersecurity issue. It's more like a watchdog.
Yeah, you could say so, but the service port, I don't know, many slides back, this one, there is a special cybersecurity application. There's also a separate application dedicated for our own system. But I said the cybersecurity application here is actually more Windows checking, port setup, either Windows system updated, or the antivirus updated, and so on. This is more general, actually. But of course, it's made with a focus on these kind of systems in our architecture. And of course, there are applications available who do the same for other Windows or in general. So my message is actually that from a general point of view, it might not be so necessary if it's an ABB software or not. The issue here is make sure you have a check of your system to give you the findings, because your systems are, I'm sure they are so complicated that you can't find everything just by normal looking, and you don't have the time to look properly.
And there's one more question regarding the cloud storage or service you have.
Yeah.
Fast charging.
Yeah. Yeah.
It's supposed to be VPN connected. So is it between what kind of hardware they be? VPN.
Yeah, we are at the moment in this new digitalization ability platform. We are launching new connected devices. Maybe you can fill in.
Yeah, the connected device on your premise will be zero ABB equipment, and it will use secure connection to the cloud. So it will not be software based, it will be hardware based. Give you the absolute maximum security. So it's just based on the set the testing for that moment. One question of PLC and the security on the device itself.
Mm-hmm.
Are you offering some kind of able to double X authentication for the PLC? or authentication for protocols being used to communicate with the PLC?
Yes, there's being hardened the communication. For instance, if you want to download new software to the controller, you can, for the news controllers, you can use a function saying if that's not the computer downloading last time, you're not allowed to download new software. And you can also select a different setup for there's a kind of gateway in the computer to communicate to the network where you can configure the authentication on the security level. You can also even say, and some of these controllers are also used in, for instance, pharmacy, where you have to have double signature to be allowed to make some changes, just like safety, SIL, seal systems, where you have to have double authentication to be able to change the software, so one person cannot do it. It's a matter of, it's not much used in normal process control or normal SCADA system, but I'm sure this is one of the measures that we will also have to look into. Possibility is there, it's maybe not so much used. Yes, I think the time is well over the deadline, and thank you for coming. Hope you can use it and make sure that your systems are not totally down because of cyber attacks.